Hello, welcome. In this section, we will look at what happens in case of collision. How do we handle collision? There are two ways to handle collisions. One is the open addressing. The other approach is separate chaining. For open addressing, we're going to look at linear probing, quadratic probing, and double hashing. So let's look at linear probing. Now, we're going to have all these elements and put into the hash table, and we're going to assume just we have the keys, and the values are not displayed. And the keys are the integer keys. And when you apply a hash function, the result of the applying this hash function on integer is still the same integer. So for simplicity. Now, linear probing is this. You're going to look at the next available position if this position is in conflict. So let's look at an example here. Suppose, and this is our table, the size is 11. And we're going to have this is the key is 44. So 44, remainder 11 is 0. 44 is right here. And this is 4. It's right here. And 16, remainder 11 is 5. It's right here. And 28, remainder 11 is 6. It's right here. And this is 21. Remainder 11 is 10. So it's right here. So now we're going to insert the element with key 26. 26, remainder 11 is 4. But this is already occupied. So linear probing will look for the next available position. This is still occupied, and then keep going down to the next one, and until you find an open addressing. So this is open, so we're going to put 26 right here. So this is the idea. Now, if you all the way going down to the end, and you need to go back to look for a new opening addressing. So here is the animation. So this is the animation, and we're going to look at this right here. We're going to put 26. So we're going to insert to 26. 26 is going to be put at this location 7. So 26. And now we do a search, same thing. So you're going to have 26, remainder 11 is 4, no match, next no match, next no match, and here's a match. So this is search. 26 is in the hash set. All right, so now let's do a delete. We're going to delete 4. So what happens when you delete a 4? You need to have a special marker here to denote this position is available for insertion, but when you perform search, you need to look for the next one. So remove it, and here's a special marker indicating this location is available for insertion. And now when you do a search for 4, so 4 is not in the hash set. And if you do a 26, and so now you still see 26 is in the hash set. This is linear probing. Linear probing, obviously, you're going to see a cluster, consecutive cluster here. Now let's look at a different way for open addressing is the quadratic addressing. So we're not going to have consecutive cluster. So what happens here is the quadratic probing is you're going to look for the next address by this quadratic jump. So the first one is this is you have this is a J and is 0, 1, 2, 3. So here when you jump it, it's quadratically, it's not linear. So here 26, the first one is right here, but the next one is 1 square, and that's 5. And then it's 2 square, and that is going to be 4 plus 4 is 8. So that's quadratic probing. So let's look at the animation. So we're going to have 26 right here. And so you can see 26 is going to come to the location at this index 8. So this is a quadratic probing. Quadratic probing, visually, you don't see a cluster consecutively, but there is a cluster based on the quadratic jump. So there is still a cluster. So it doesn't really help much. Next, we're going to have double hashing. So how much you jump is not a fixed. It's going to be based on the key. So this is the double hashing. And we're going to introduce this double hashing. So the first hashing is you have the key, you map it to a value. So that's the hashing. And now the second one here is we're going to have this h prime. And we use j times h prime. So for example, we're going to define this k prime here is 7 minus key remainder 7. So this is the one here. Now, if the key is 12, and you're going to see this, h prime 12 is 2. All right, so please note that this is here, and this is the amount you jump is dependent on this h prime and key value. So this is a j. J is initially 0, then 1, 2, 3, 4. Okay. All right, let's look at this example here. So we have this is the keys. We're going to use 12. So 12, and here the first one, remainder 11 is 1. It's right here. It's occupied. Now, what about the next one? The next one is here, plus 2. So because the h prime 12 is 2, so this is plus 2, it's right here. And then you're going to plus 2 times 2 is 4. It's here 5. So that is, and how you get this 26 plus. So 1 is occupied, 3 is occupied, and here is you are going to have right here is 5. So here is 5. Okay. So I'm going to go to look at the this is, oh, I'm using 26. Sorry, I'm using 26. Let's remove 26 now. So to match the one here in this example, I'm going to use 12. So you're going to put 12 right here. 12 is going to be here at 5. It's right here. Well, 26 is going to be here. So so if you use 26, first one is 26, remainder 11 is right here. And then what is the, you need to compute this h prime 26 and see what is the value of this. Do some calculation. So you're going to find out. And here it's going to be coming to this one. Through the jump and eventually and come to this. So this is double hashing, and double hashing is obviously is going to be better because it's not a fixed jump. It depends on the key value to determine the jump. That is all for handling collisions using open addressing. In the next video, we will look at handling collisions using separate chaining. See you next time.